Simply installing a speed monitoring unit is not sufficient to prevent damage to people and equipment. It is the customer's responsibility to implement appropriate safety measures for equipment that use the robot. It is crucial to assess the risks and take the appropriate countermeasures. If a person may be working within the robot's range of motion, the facility should be designed to provide a safe distance between the robot's work area and the person. This video explains the area monitoring settings that can be used as reference for facility design, as well as the approximate stopping distance and stopping time for each robot. Here, we plan out the maximum stopping distance before the safety function activates and the robot stops. If the robot is moving at high speeds of 250 mm per second or more, design your facility so that people do not come near the robot. Stopping distances may vary depending on the operating conditions, the status of the robot and other factors. Make sure to check the stopping distance in the robot's actual usage environment, as well as whether the safety functions are operating correctly. For SCARA robots, calculate the stopping distance by referring to the stopping time and stopping distance at emergency stop in the installation manual for the robot in question. First, calculate the movement speed percentage of the monitoring speed, based on the maximum speed of the XY axis listed in the installation manual. Here, we use an example where the movement speed percentage of a YK400XE SCARA robot is calculated with a monitoring speed of 250 mm per second. Since the maximum combined XY axis speed of the YK400XE is 6 meters per second, the movement speed ratio is calculated to be 5%. Round up to the first decimal place. The maximum speed was calculated as 5%, in order to monitor under the assumption that the robot's speed does not exceed 250 mm per second. Next, based on the calculated speed, refer to stopping time and stopping distance at emergency stop in the installation manual to read the arm stop angles for the X and Y axes. The example shown here is for the YK400XE with a tip weight of 4 kilograms and an operating speed of 5%. From the graph, when we read the XY axis stopping rotation angle with an operating speed of 5% and a tip weight of 4 kilograms, we get approximately 5 degrees for the X-axis and 4 degrees for the Y-axis. Next, we calculate the stopping distance based on the stopping angle that was read. The maximum stopping distance is the distance that the tip of the robot moves on the XY coordinates when only the stopping angle is changed from the robot's fully extended position, as shown in the illustration. This maximum stopping distance can be calculated using this formula. Since PSX is 0.0 mm and PSY is YK400XE, the result is 400.0 mm. For PEX and PEY, based on an X-axis arm length of 225.0 mm with a stopping angle of 5 degrees, and a Y-axis arm length of 175.0 mm with a stopping angle of 4 degrees, PEX is 46.99 mm and PEY is 396.99 mm. Using these numbers, the maximum stopping distance is calculated to be 47.09 mm. The stopping distance during emergency stop in the installation manual does not account for the length of the end effector. If an end effector is attached to the tip of the robot arm, add the maximum length of the end effector to the stopping distance to ensure a safety perimeter. SCARA robots can perform monitoring using XY coordinates. The relationship between XY area monitoring and maximum stopping distance is as shown in the illustration. For more information on XY area monitoring, refer to the RCX3-SMU parameters video. Design your safety fences and other measures by considering the maximum stopping distance for XY area monitoring, leaving plenty of room so that workers do not interfere with the robot's operations. The stopping distance for a Cartesian robot can be roughly estimated from the SS1R/T deceleration monitoring conditions. First, Run the deceleration monitor configuration wizard to set the deceleration monitor parameters. The stopping distance for each axis can be calculated using this formula. The monitoring area for Cartesian robots is set using the area soft limit parameter. For Cartesian robots, even if the XY travel range is the same, the range that the actual axis can reach varies depending on the robot's configuration. Determine the area by limiting the motor's movable range while checking the robot's configuration and actual operations. If an end effector is attached to the tip of the robot arm, set the area soft limit for the monitoring area with consideration to the position at which the end effector is at its maximum length. The area from the monitoring area that you set to the position of maximum stopping distance is to be considered as the hazardous area, within which the robot may operate. Design your safety fences and other measures by considering this area, leaving a safety perimeter so that workers do not come near this area or interfere with the robot's operations. Here, we plan out the stopping time before the safety function activates and the robot stops. This gives a reference for the approximate stopping time of the robot when designing your own facilities. Stopping times may vary depending on the operating conditions, the status of the robot and other factors. Make sure to check the stopping time in the robot's actual usage environment, as well as whether the safety functions are operating correctly. Consider a maximum of 100 ms for the filter delay, detection time and so forth, aside from the time required for the robot to actually stop once the safety function is activated. This does not include the time during which an external safety input device detects a hazard and opens the output signal to the SMU. For SCARA robots, calculate the stopping time by referring to the stopping time and stopping distance at emergency stop in the installation manual for the robot in question, and reading the stopping time for the X and Y axes. The example shown here is for the YK400XE SCARA robot with a tip weight of 4 kg and an operating speed of 100%. From the graph, for an operating speed of 100% and a tip weight of 4 kg, we get approximately half a second for the XY axis stopping time. We add a maximum response time of 100 milliseconds to this, to get the total stopping time required before the safety function activates and the robot stops. For a Cartesian robot, the stopping time is the time set in the SS1 timeout parameter. We add a maximum response time of 100 milliseconds to this, to get the total stopping time required before the safety function activates and the robot stops. Use this information when setting the opening time for the locking type door sensor, considering the stopping time before the safety function activates and the robot stops. That is all for the facility design.